this video, we're going to be talking about solving systems by elimination. So there are 4 steps to solve a system by elimination. The first one is to multiply one or both equations, so at least one variable has opposite coefficients. And so opposite, I'm meaning positive and negative. Step 2 is to add your new equations to eliminate one variable. Solve the remaining equation and then substitute the value from step 3 into one of the original equations and solve for the other variable. So let's go through some examples that show these steps. So at number 1, we have the system 2x plus 8y equals 8, 5x minus 8y equals 20. So what we're looking for in solving systems by elimination is that we want for one of our variables to have the same number in front but opposite signs, so that when we add it, my variable cancels out. Here I see I already have one. With my y value, I see that my top equation has a positive 8 and my bottom equation has a negative 8. So when I add these two equations together, my y's cancel out, and I'm left with 2x plus 5x, which is 7x, is equal to 8 plus 20, which is 28. And then solving that, I can divide both sides by 7, and I get that x is equal to 4. So I have a value of one variable. Now I need to find the value of y. From here, I can choose to substitute x into either the first or second equation. I'm going to go ahead and put it in the first equation. So when I do that, I have 2 times x, which is 4, plus 8y is equal to 8. 2 times 4, I get 8, plus 8y is equal to 8. Subtract 8 from both sides, and I get 8y is equal to 0. And then divide both sides by 8, and I get that y is equal to 0. So I have my x value, I have my y value. Last step is to go ahead and write that as an ordered pair. So I put my x value first, which is 4, my y value second. Okay, let's look at another one. This one has 3x plus 7y is equal to 15, 5x plus 2y is equal to negative 4. Now, looking at this one, at the coefficients in front of x and y, I see for x I have 3 and 5, for y I have 7 and 2. So I don't have the same number in front, and they're also all the same sign. So I'm going to have to multiply both of these equations by number so that I can get these to be the same number in front of either one. So it doesn't matter which one you choose, I'm going to go with x. And to make them the same number, I'm going to multiply this top equation by 5. And then I'm going to multiply this bottom equation by negative 3, since I also want them to be opposite signs. So when I do that, I get 5 times 3, which is 15x, plus 5 times 7, which is 35y, is equal to 15 times 5, which is 75. And then distributing that negative 3, I get negative 3 times 5x to get negative 15x. Negative 3 times 2y to get negative 6y is equal to negative 4 times negative 3, which is 12. So I see when I multiplied both equations now in front of my x, I have a 15 and I have a negative 15. So when I add these equations, my x's cancel, and I'm left with 35y minus 6y, which is 29y. It's equal to 75 plus 12, which is 87. And then dividing both sides by 29, I get that y is equal to 3. So I have my y value, and now I need to find my x value. It doesn't matter which one you plug it in. I'm going to go ahead just to do something different. I'm going to plug it into the second equation. So I have 5x plus 2 times y, which we found to be 3, is equal to negative 4. 2 times 3, I get 6. Subtract 6 from both sides, and I get that 5x is equal to negative 10. And then divide both sides by 5, and I get that x is equal to negative 2. So I have my x value, I have my y value. Now I'm going to write that as an ordered pair, and I get negative 2, 3. My x first, my y second. Okay, looking at this next one, I have negative x plus y equals negative 2, and 4x minus 4y is equal to 0. So here I see that my coefficients in front of x and y in the top equation are negative 1 and 1, and then the bottom equation are 4 and negative 4. So this one I don't actually have to multiply both equations by number. I can multiply this top equation if I was wanting to eliminate x by 4. So that way my top equation will have negative 4x while my bottom equation is positive 4x. So when I multiply out by 4, I get negative 4x plus 4y is equal to negative 8. And then my bottom equation, I have 4x minus 4y is equal to 0. And now we see something different happens here. I see that my x's cancel because negative 4x plus 4x is 0. I see my y's also cancel because 4y minus 4y is also 0. So I end up with 0 on the left-hand side is equal to negative 8 plus 0, which is negative 8. So I see in this equation I end up with 0 equals negative 8, which is not true. So whenever this happens, this is going to be no solution. So that means if I were to graph both of these lines, they would be parallel lines. Okay, now let's look at one more. So here I have 8x plus 2y is equal to 12, and 12x plus 3y is equal to 18. So I don't have any variables that have the same number in front but opposite signs, so I'm going to have to do some multiplication. I like to stick with the smaller numbers, so I'm going to go ahead and eliminate my y's. And so that means I'm going to multiply this top equation by 3. Which is just the coefficient of my bottom. And then I'm going to multiply this bottom equation by negative 2. So multiplying this top equation by 3, I get 24x plus 6y is equal to 36. Multiplying this bottom equation, I get negative 24x minus 6y is equal to negative 36. So I see my x's cancel like I wanted them to. I see my y's also cancel here because 6y minus 6y is 0. So I end up with 0 on the left-hand side. And then on the right-hand side, 36 minus 36 is also 0. So here I end up with a true statement. 0 is equal to 0. So since I end up with a true statement, the answer here is going to be infinitely many solutions.